In this particular question, we're given a demand function, d of p equals square root of 400 minus 3p, and that's my Q quantity. Remember, here's our price as our independent variable, and then there's our dependent variable. So I just rewrote this function, demand function, and the reason I did this is because we'll have to do the derivative down here. But anyway, I just rewrote that function and find elasticity of demand at price of $2. So from your textbook, in page 152, we're given the elasticity of demand. It's where I take P over Q times the derivative of Q with respect to P. And these are absolute values. So whatever answer we get, if it's negative in here, it's going to end up being positive. So here we put our Q in, P over Q, and then I needed to find the derivative of the Q function, so I can plug it in into this section. And rewrote it, so I bring down my 1/2 using the power rule, subtract 1 from 1/2, I get a negative 1/2, and then using the chain rule, I have to do derivative of the function inside, and I get negative 3. So there's my derivative, and again, I just rewrote it here. So I plug it into the d of q with respect to p, so the derivative of q with respect to p. And at this point, I can just plug in, we're given the price, we want to find the elasticity of demand at $2. So wherever I have a p, I plug in my 2. And so as you can see, I went through and solved, or simplified at this point. And when I plug all this in my calculator, I end up with an elasticity of an absolute value of a negative 0.00761. Now I did round this value, and the absolute value means this is going to be positive. So our elasticity is 0.00761. And if we refer back to the textbook, which I'll just put it right here, and what does that tell us? Well, if that is less than 1, which ours was, that means it's inelastic, and that in this case, raising prices would increase revenue. So, as you can see, raising prices would increase revenue for this particular question.